Hello. Have you made a few simple arcade type games in Godot or another engine? And are you wondering how you can make a much more complicated game, a game with perhaps over 100 unique characters, perhaps 151, and hundreds of moves that are expressive and complicated and unique? Not impossible if you get beyond if statements to check if Mario's moving left or right. With clever architecture, we can really express ourselves with a huge amount of content that is editable and configurable not just in code but easily by your non-technical teammates, so you can get them working on it too. And by understanding and learning this, you'll become a better programmer and, dare I say it, a better person. I'm making this series to get you thinking about architecture, about design patterns, and about how to grow a project into something much larger. Some of the decisions I make are made because I've thought about them a lot and I will talk about them to you, and others are not great and you're going to have to consider them yourself and eventually throw them out. But I will be able to get you to a point where you are hopefully making those choices in an informed way. So what are we making? We're going to be making a mock version of the Generation 1 Pokemon battle system. You'll have some monsters that you'll be able to swap in and out. Each one of them will have moves it can use. Each one of them will be able to level up and learn new moves. You'll be able to use moves and inflict conditions on enemy monsters or yourself. You'll be able to use items on your monsters, and you'll be able to run away. However, that's just for the player. We're also designing for a non-technical designer who might be able to come into your Godot. This could also be you, but basically all content in the game that isn't very low-level mechanics, all content such as every monster species, every move, all effects, like special effects, audio, visual, animations, that kind of thing. Those should be able to be defined outside of code and configured outside of code. So a non-technical designer on your team can make a new monster that has unique moves, that inflict unique conditions, and set up a state where they can test that with a new trainer in the game. We are going to use some pretty ugly graphics that I made myself that are at least related to the Game Boy graphics. We can't use anything that is proprietary to Pokemon. It won't look beautiful. The nice thing though is that we are making a architecture in which the display layer is going to be totally isolated from all of the mechanical code. So you will be able to, when you feel like it, replace the entire graphics. If you want, you could replace it with 3D graphics like modern Pokemon, or with much nicer 2D graphics than I am providing. I didn't want us to get hung up on graphics here, and also I'm bad at making them. I do want to make sure that we can sequence interesting graphical calls, such as calling projectiles or animations. So we will be handling that. Those animations are going to be ugly pixel art that I drew, not anything beautiful. So that's basically the scope I have planned for now. I think this will take about 8 to 12 videos to get out, so it's quite a large project, I suppose. At the end of that, though, I am willing to take suggestions on what you want to learn next, what we can add to the project. We could do things like multiplayer, or a 3D environment, or even a kind of adventure mode like the rest of Pokemon, not just the battle system. We could deal with saving and loading, with serialization, and any number of other things. Just let me know in the comments what you're interested in learning, and we can move there after I'm done the main part of this course. So think about that. In this video, we're going to get the starter project. It mostly just has a bunch of UI set up for you because I didn't want to go through futzing with that. It can be very finicky, although not too complicated. You'll get a taste of it as we use it. Next, we will make our first code change. We're just going to hook up the run button, which will exit the program. Third, we're going to talk about a pattern we're going to use over and over again, and that is the resource and data class pattern. And we will implement that next by creating a monster species resource that will be held by a monster data class. Then we'll have the monsters showing on screen using whatever sprite we pick for them, and that's basically the major stuff for this video. All right, let's get the starter code. So you'll want to go to this address here, github.com/hoveringskull/let's build a monster battler. I will put a link on screen and also in the description of the video so you don't have to type anything. It shouldn't be hard to find. So here you are. We want to make sure we're on the main branch. I'm going to keep the main branch the starter code. So you can just make sure it's main. It should default to that. That's fine. Now, if you already know how to use Git, this should be pretty simple for you. Otherwise, I recommend getting a client like the GitHub for Windows. You could just do GitHub for Windows in Google or whatever your search engine of choice is, and it will take you to download GitHub Desktop, and you can set that up. That looks a bit like this here. Anyways, so what you'll want to do once you have that set up is click on code here, and you can grab this, or you can click on open with GitHub for desktop. If you copy this and you go into GitHub, you can go to file, clone repository, go to URL and paste in that URL. And then you want to give it a folder here. I already have this folder on, so you can type whatever you want, and that will work. And click on clone, and that will just build that for you. You could also fork it if you wish. That will only work if you're logged in. And if you know how to do that, that's a good option also. You could just download the whole thing here, click on code, download zip, and that will just toss a zip into wherever you want it to go. Great. We are building this in Godot 4.4. It should work in other Godot 4.x builds, but if you want maximum compatibility, 4.4.1 should work great. Go to godotengine.org and click on download here. If you want a previous version, if a newer version's out, you can click on previous version and get whatever you want, but we're just going to grab the latest 4.4. You don't need .NET for this because we're not doing C#. I'm doing GDScript because I think it's easier to explain, even though it does lack a lot of features. You can just download that and run it. When that runs, you'll see something like this. Click on import and then find your script. Click on game and select current folder. Click on import, and it will be running for you. It'll look like this a bit once it loads in, very fast because it's Godot and not Unity. And we can click on 2D to see this beautiful art. There's two turtles. That's great. And that's all you need to do to get this set up. All right, let's get our hands dirty with a first edit. So if we play the game right now, there isn't very much interaction. We can click on fight and there are a few buttons, but everything else does nothing. The very first thing I think we want to do doesn't involve data at all. We're just going to hook the run button up to a function that will quit the game. This is one of the most important things a game can have, I think, a way to quit. In a very simple project, we could just run the quit function from the UI component, but we want to introduce the separation of UI code from game code that I mentioned before, and we are going to go into more detail on this in the next video, I think. Let's do this the right way. We're going to open up the main scene here and find the controls menu and click on that little scene button so that we can open up the controls with toggle visibility there. The functionality we want is actually just in the menu script here. Click to open up the battlemenu.gd script. If we look around, we'll see that there is a select run button. We'll see that the select run has a pressed signal that's connected to a handle select run, and handle select run does nothing here. So the way we want to do this is send a message to a controller script, which is going to be the game runner. And game runner is going to run a quit function for us. To do this, we will need to use a signal. We're going to make a new event for this. So let's go into scripts/infra/events.gd. Signals here in the events sent from UI section are requests based on button presses and similar input. We can do a signal request menu run. And let's go to the battle menu again. We'll find the function handle select run. We're going to emit the signal from here. And I mentioned before that events is a global singleton script, so we can refer to it with a capitalized events.requestmenurun.emit. I typed it wrong here, so we'll fix this later. This is going to send our signal, and now we just need to catch it. So from game runner in ready, we could say events.requestmenurun, and then we can make a new function called handle run. Well, first let's make it just quit the game, but later we're going to add a little delay and log a message. So let's see if we can get it to quit for us. So to quit, all we have to do is getTree.quit, and we'll see if that works. So if this works, when we click on the quit button, it's going to emit this, and it will be caught here, and then it will quit the game. So let's see if that works. It's not showing because I turned the visibility controls off. So make sure that that's visible. And it didn't work again because I had typed the wrong signal name, which is easy to fix. There we go. So let's add a little pizzazz to this. Let's log something out on the right here. I've created a little log service. It might look like complex code, but it's just accepting stuff from an events.requestLog signal and spitting it out on the right here. Let's try that out. If we do events.requestLog, you can say that you run away. Your cowardice will not be forgotten. Now, if we run this again, it populates the log on the right side over here. Sweet. So in order to have a timer here, we can go to var timer equals timer.new. We have to add it to the node here, and then we just do timer.waittime equals, we'll do 2 seconds. And on the timeout signal, we want to quit. So when the timer times out, it should quit the game for us after about 2 seconds. Let's try doing that again and see if there's a 2-second delay. And it didn't work because we forgot to start the timer. So timer.start. There we go. It's fairly simple, but this is the kind of interaction flow that we will have with our UI. UI will always be updated from controllers using requests, and controllers will be receiving events from the UI using other signals. The benefit of this is that we don't rely on any specific UI implementations and can change out our graphics freely, which you might want to do because All right, we'll get into some more interesting stuff after this. What is a monster? Let's think a bit about Pokemon, which we are taking some inspiration from. The Pokemon Ash's Pikachu is one Pokemon that has a species which is also Pikachu. Yes, this is a very confusing example because in the show and video game Pokemon, they just refer to Pokemon by their species, as if I point at you and say, hey human, but it's what we're working with. Anyways, what we want to do in our first data modeling task is to figure out the relationship between a monster and its species. And this is going to be the first of many tasks where we separate things into a data class that has the information about an individual and have it point to a resource class which has information about some sort of category of content that is authorable by us as game designers. Let's get started. I'd like to invite you to play along at home here, but right on this page here, I've got a non-exhaustive list of types of information a Pokemon could have. And you can add more. Again, it's non-exhaustive, and just think of everything possible about a monster. So what I've also put here is 2 categories here. So there's individual monster and species, and we want to decide which things here belong where. And some of them are very clear. So something like, well, let's say um, species description is obviously part of species. Something like moves that can learn on level up is also definitely a species thing. However, something like the actual moves that it has is probably something a monster has to hold because it can change from monster to monster, right? Not every single level 12 Squirtle is going to have the same moves because you can change them through various means, right? Something like experience has to be belonging to the individual monster because a species doesn't carry experience on its own. Species itself, oddly, is something a monster has to refer to, right? So a monster is going to have a reference to the species it belongs to. A nickname, definitely a monster thing, but the name of the species, we can actually make a new note for this, belongs on species. And probably if you are asking for a monster's name and it doesn't have a nickname, we will fall back to the species name. Height and weight is a weird one because it's one of those things that is defined by the species, but is individual to the monster. But it also doesn't really matter that much because it's just flavor, right? At least in this generation. Active conditions, since they are things that are currently happening and aren't happening to everyone in a species, that would go to an individual monster. But if we were implementing later generation things like that had, I don't know, passive abilities or something, we could also have conditions that are species based. Current stats is a weird one because it will be influenced by the species. For instance, the base stats is probably a species value. Current stats, well, it's going to be derived from a bunch of things, but accessed through the individual. Max hit points, well, that's probably wherever current stats are is a max hit points thing, but current hit points is definitely a monster thing. How fast its stats grow, I think might be influenced by both, because we'll implement something later like the effort values or whatever that are how fast stats grow, which are individual to a monster, but the base stats, I believe, should also impact that too. Type, well, that's probably a species thing, unless you're really changing the design of Pokemon. And level should just go with experience. So the idea here is that there are some values that are species based and some that are going to be individual to the monster, and a monster will have a species and thus can access these two. Because we're going to be implementing species with a resource, which I'll show you soon, we will be able to build species out just as resources within Godot and access them really easily without having to code a new file for every species. So that will be pretty cool. All right. If you want to see how we express this in code, let's move on to the next part. So before we code, let's figure out how we're going to code this. Naively, we might look at something like inheritance as a way to deal with this. There is the classic example of dog is animal and cat is animal, so they should both inherit the animal class. And with this, we'd have a monster class, and Pikachu would inherit from it, and Squirtle would inherit from it, and Charizard would inherit from it, and they'd all have their own functionality in their own class. But then when we look at this, we realize that the functionality of each Pokemon is pretty much the same. What differs is a little bit of data, like their statistics, and what moves they have and can do. So really what makes much more sense is if we make a class that just holds all of that data. And that way we can have something like the species class, which is going to inherit from resource and will be instantiatable as many resources as we want without having any extra code to maintain. All right, let's code this out. The first thing we want to do is make a species resource type. So let's go into scripts and into content. You may have to make this folder, create new script, not resource. and we'll call it species underscore resource.gd. So it'll automatically extend node, but that is not correct. It needs to extend resource. And if it extends resource and we also give it a class name, it can appear in the resource menu when you try to instantiate one. So we've got a species resource here. Now, if you click anywhere in this file system panel, right click, you'll see create new resource, and you can probably type in species and it will show up, and we could make one, but it doesn't have anything in it right now. So let's hold off. Great, we can create species resources now. Let's add a couple important fields here, and we'll add some more things later as we need them. Let's start with a name and an image. We have to use @export so that it will expose the properties in the inspector. Image is going to be a texture 2D, and the name is going to be a string, of course. And let's also define, say, a max hit points. This might live on individual monsters eventually, but for now, let's define them on a species resource. These data models will change as we grow the game, and that's okay. It's better to do it now than once the game's released. All right, cool. We can make a species now. I'm going to go into res. I'm going to create a new folder called content. This is where all of our resources are going to live. We're going to create a new folder in here called species. And then in that folder, we can right click. We can click on create new resource. And if we click on that again, we'll get species resource if we search it up. And let's call this one, let's say salamander. If I can spell it. Now let's double click on that, and you should see on the right side panel here our data fields. So I'll give it a name here, salamander, and we can give it an image. Just click on, well, we'll go to the file panel here, and in assets art, you can grab some of my beautiful pixel art. And we'll give it a max hit points. This is all easily tweakable now. We just have to click on this content resource and change it. Great. Let's make another one. Let's make a species resource. We'll call this one turtle. And here you go. Go get some more beautiful pixel art, and you can give it a name. And max hit points in this case, we'll make it tougher. Turtles are tougher than salamanders. Everybody knows this. So that's fine. How do we use these? Well, we're going to need a monster data class that can hold a species resource class. And we'll have to instantiate the monster data class somewhere and have it live somewhere. So where's that? Or let's go to scripts and then a folder called data. You might have to make that folder. And then create a script called monster. This is going to be our monster data class. What does the monster data class get? Well, it doesn't need to extend a node because we're never going to add it to the scene tree. It's just going to hold data for us. And we should give it a var for species. It doesn't have to have export because we don't actually export it. And a var for hit points, or HP, which is an int. If you're having trouble with species resource there, it might be because you forgot the class name. Okay, cool. First of all, how are we going to add these data objects to our game? And second, how are we going to show them on the UI? So we'll handle the first thing first here. Let's instantiate them into the game. So for convenience, for now, let's use our game runner. You can do Control P on a PC at least, and search up the name of any script. I recommend doing it this way. Look up game runner, and here we are. Well, let's see. We have this ready function here that runs whenever this node is added to the tree. So that should be good for us. We can call something like setup model from there. So I'm making a setup model function, and we call that in ready. Cool. Okay. So what do we do here? Well, we need somewhere to hold our monsters. We'll start with just having a player monster and an enemy monster or opponent monster. So in data, let's make another new class and call this game state. This is going to be our top level sort of class for all state in the game. And it is going to be how we store our current monsters for now. So again, this cannot be a node because it's just a data class. And add some variables here. Player monster is a monster and opponent monster is also a monster. So you're going to see that we're having an error here for not being able to find type monster, and that's because monster does not have a class name. So make sure it gets class name monster. Okay, problem solved. In GameRunner, let's now set up our new game state. So in setup model, which you are calling from ready, we can now create a new game state. We'll create a top level variable here for game state in GameRunner. It's going to be, we need a class for it, of course. Add a class name for game state. And there you go, that will create one for us, but let's not have it instantiated there. We can instantiate it in setup model. So game state equals gamestate.new. Okay, what do we do to set up game state? Well, we need to create two monsters. In order to get our species here, the simplest way is to just run a preload here. So let's get our two species classes, or our two species resources in memory here. We'll do species salamander, we can do preload, and then it will help you find it here. You might have to do some typing. I recommend you can do res, you know it's going to be in content / species salamander. And we'll do the same thing for the turtle. Preload, res, content, turtle. Wonderful. All right, now we just need to make some monsters. So our first monster is going to be the player monster. And we just set its species here. Species dot salamander. And this is definitely not the best place to be doing this, and we will be refactoring later because this will get repetitive here, and really all this setup for monsters does not belong in the game runner. But for now, this is okay. We create a second monster for our turtle. And voila. And then one other thing we should do is just make sure we set the HP for these two guys. So we'll set it to species.max HP. We're not doing any checks on HP or anything yet, but we will be doing that later. And we'll also be moving all of this into some sort of repeatable function later because this is a bit repetitive. Great. Okay. And what's the last thing we have to do here? Well, we have to make sure that we actually set this on the game runner. So let's do that. On the game state. We have to set this on the game state. So player monster, monster 1, game state dot opponent monster, monster 2. All right. How do we test this without a UI? Well, we're just going to, we can just use a debugger. So I'm going to put a return here so I can debug it. And then if we play the game, we get stopped here and we can look at the stack trace down here, which is a little hard to pull up. And you can see we have monster 1 and monster 2, but importantly, game state, if we click on it, has two objects in it. We can click on each one and see that one species salamander. and the other is presumably species turtle. All right. That seems to be working. And of course, nothing is showing up in UI yet, but next thing we are going to do is make sure the UI is updated to reflect the new model. In our main scene here, we've got these two turtles. They are in Mon renderer modules here. We can click on Open an Editor over here to find out about these two scenes. See, we've got a script attached here. We can open it. I've already added a lot of stuff to this script, but it's really only just internal nodes being hooked up. We have labels connected and a hit point bar as a progress bar, etc. Just so we don't have to bother doing that right now. The main issue here is this thing just doesn't actually do anything yet. It needs to know when it needs to start to listen for monster changes, and it needs to know which monster to listen for. So let's have a look at our events. We don't actually have anything for this, so we're going to make something. Once we've added these monsters as our opponent monster and our player monster, we want to emit an event saying that they have been added, and this module and the other one will connect to that event. So let's make a new event. I'm going to call it on monster added to battle. It's something emitted from the model. And we're going to call this with two arguments. One will be the monster itself, and the other will be a Boolean that represents whether it's the player monster or an opponent monster. So let's just emit it, and we can work on connecting it after. Here we are in Game Runner. This is where we're adding those monsters, if you recall from a few minutes ago. And we can do events, find it here so we don't misspell it, on monster added to battle.emit. We're emitting the monster, monster1, and then true. That represents that it's the player monster. And we'll do the exact same thing for monster 2. And you better make sure you spell this right or else it will not work. False represents opponent monster. Next, let's mark which one of these modules is the player one and which one is the opponent one. So have a look at monster renderer module again, and we'll look up here, and you'll see we have this Boolean your POV. This is something we want to be able to set to indicate that a module is supposed to receive the player's monster and track that. So if we look in the inspector here on the side, we want to change mon renderer module 2 to have your POV on. Then save that scene with Control S. So in monster renderer module .ready, let's listen for an event. Events.on monster added to battle.connect, and we need to give it a function. I'm going to call it maybe add monster, or maybe yeah, and it's going to take a monster, and it's going to take a isPlayer monster Boolean, which is going to match the your POV. Okay, first let's check if your POV is equal to isPlayer monster. This way we're only going to add the monster to one of the modules, not to both of them. I'm going to update this to be maybe bind monster. That's a little more clear to me. Great. Now, what do we have here? I'm going to make a variable for bound monster. This is a non-exported one, and it will just store the current bound monster. So let's bind this monster. And then we want to do something to update all of the labels and such if the bound monster is bound. So I'm going to make a update function, I think. So update will just go over each one of our labels, but let's look at what we want to update first. You can see the labels. We've got the progress bar, we have the name, we have the hit point label, and we've got this frame that's got a monster sprite. We'll handle the condition text later. Back in script, let's update some things with this update. So we can do things like name. So let's start with name. Name label.text is boundmonster.species.name, and I'm going to make it to upper so that it looks a little better in the digital text we're using. And we can do, first we'll do the sprite texture is boundmonster.species.image. That should work. HP bar will take a max value and a value. So we'll just get the boundmonster.species.maxhp for max value, and value is going to equal boundmonster.hp. Great. And then the HP label, we can just format some text for this. So let's type this out. In curly braces, we can put the first value, we're going to do a slash here, and we're going to do the second value. And we can format it using a dictionary. Look up string formatting in GDScript if this is confusing to you. And there's still a problem, and that's because of this slash here. It's actually escaping the curly brace so that it will display it. We could use a forward slash if we want, or we could just use 2 backslashes because that will escape the backslash itself. Let's do 2 backslashes. That should work fine. Also, before we run update, we should really check if the bound monster is null. And if it is, we should not run any of this because it will give us a ton of errors and not look right. Take the project here. And, well, nothing happens. The 2 monsters did not change even though we run that code, we think. So what's going on? One thing we can check here is when these update or bind methods are called. So let's check when this code is run and when the setup model is run. I'm using some print statements here. This can be a really quick way to check what order anything is called in. So we'll see that the bind is actually never called, so that's a bit interesting. This will happen all the time. When you're using these signals, you really have to be clear on when things are happening. Let's check when this ready is running, because if this event is being bound after it's being emitted, then it will not be emitted. And that's the problem. So we can see the big problem is that we do not connect to the event until after it's been emitted. We can't guarantee the order of ready scripts, so we're going to need a better way to orchestrate the UI. So we're going to go to battlerenderer.gd. This is a sort of top-level class for all of the current UI. And it actually has references already to our 2 modules, and they're already set up for us here. So let's make a new ready function for it. And we want to orchestrate in what order these scripts connect their events. So I'm going to rename this ready into connect, so it's not going to be run by Godot, but instead by BattleRunner here. In BattleRunner's ready, we can run connect events for each of these. And then at this point in the code, we know that the events are connected. So then we want to emit some sort of event that can be caught by the game runner saying that it's okay to make the model now. Since this is a request coming directly from the UI, we could do a request up here, but since it's kind of a weird one, it's not like a user initiated request, I'm going to make it a on UI ready request in this internal section, which doesn't follow the same rules. You could argue for it going in another place too. Cool. So we've got this event. We can emit it here. It doesn't need any fancy arguments or anything. It just needs to send a signal saying that this has happened. Then in our game runner, we just need to connect to that. And then we know that we can set up the model after on UI ready is called. Okay, so now it is running in the right order, and it looks like everything is rendering properly. We now have a beautiful salamander and a beautiful turtle. Let's remove all these print statements here. The last thing we really need to do is swap the order of the player monster so that it appears before its status text here. It should be on the left side, not on the right side. So to do this, let's go to mon-renderer module, and we can do this in bind here because it will only ever happen once. It doesn't need to be run every time we update the monster. And let's look. So the way that this gets rendered is it just depends on the order. So what we can do is just move the child called frame, and we move it to a different index depending on if it's your POV or not. So we're going to use a ternary statement here, and we're going to ask for index 0 if it is player model, and index 1 if it's not. Great. And we only want to do this if it's a successful bind. Cool. Now let's have a look at the ordering of our beautiful salamander. Okay, look, it's looking a lot better now. It's on the correct side, so this is great. Let's close this. Okay, so that's the basics of setting up our rendering. We do need to connect up some sort of functionality for when there's a change so that we can update things like the hit point bar. But in that case, all we have to do is call this update function again. And we'll hook that up once we have some changes happening in the model. All right, that's enough for today. So what have we got done? We have our sample project started, we've started our data model, we have our creature data type, our species resource type, and we understand this pattern, which we're going to reuse, and you can reuse in your own projects, of the data type and the resource type. We've also got our creatures rendering statically on the screen. That's big. A few thoughts. This probably feels a bit slower than other tutorials. We are taking our time to build up a foundation that will let us implement mechanics faster in the future. You might be worried that when you're working on your own project, you won't be able to make these decisions. And I think the sad truth about videos like this is that I am obfuscating that I have already essentially built this project and I'm rebuilding it for this. And when I built it the first time, I made a lot of really strange decisions and had to go back on them and fix them. However, every time I build a game, I get a little better at it. And I hope I can pass some of that on to you. And I hope I can also remember to talk about the challenges I had and that I beat while building these. You also might think, many of the choices we're making is not how real Pokemon works. And I don't care. We're using the structure of Pokemon to build an architecture that could express all of the mechanics of Pokemon, but mostly we care about architecture that can quickly build any game mechanic. And you can adjust yours to be as close to Gen 1 Pokemon as you want. In fact, I'm going to put a link up here somewhere. Someone's decompiled the code for Pokemon Red, and you can read through it, and it's pretty interesting. It's an assembly, but a lot of the kind of value types are pretty cool to look at. I'll put up some here to see. We don't have to do it this way, because when people were programming Pokemon for the Game Boy, they had half a megabyte to fill up, and we can be much more expressive and have much better, more maintainable code if we have a little more space. And don't come at me with, that's why games today are bloated thousands of gigabytes and filling up my whole PlayStation. That's not why. Code takes up, I don't know, megabytes at worst, and probably much less for almost any game. Code's nothing. All of that is textures and audio. All right, so what's next? If you're watching this fresh, I'm going to release the next video in about a week. So please like, subscribe, and whatever. And tell your mom to subscribe too. This is a fledgling channel. I would really like to get her on my side here. In the next video, I'm going to talk code architecture. We're going to clean up our monster code, and we'll add the monster swapping mechanic. That should clear us up to start implementing monster moves soon. If you have any questions, feedback, or insults to hurl at me, please do that in the comment section. And I hope you had fun, or at least learned something. All right, see you soon.